Hi, hello students, how are you? I hope you are doing well. Yes, my name is Shadab and I am your physics master teacher here in Vedantu. And this is one more class, another episode of master class, and this is your master class of gravitation physics for JEE as well as NEET. Gravitation is a very important topic for you people, for JEE aspirants as well as for NEET aspirant. Right? So now what we have to do today, we have to discuss some very important questions, or we can say some must question for gravitation. So here it is. Okay, so let's start fast track revision of physics gravitation, that is for very important for JEE and NEET. And dear students, please be ready with your pen and notebook, because you have to note each and everything here, because it's a fast track revision and you will get many important points and concepts and also the tricks. Right? So chaliye shuru kar dein. Okay, so let's start the gravitation. The first question for you people is here. See, a very easy and simple question. First, just read carefully what the question is. So the question is, suppose that the angular velocity, see here, what is the question? Question is, suppose that the angular velocity of rotation of Earth increased, right? Then what is the result? So first we have to think what is actually the effect of rotation. So my dear students, you already know, due to the rotation there is a decrement in gravitational acceleration at the surface with latitude. So, and you know the equation for this, G dash is equal to G at the surface minus RE omega square and cos square lambda. So this is the formula for this concept or this question. What's lambda? Lambda is actually the latitude. How can we define the latitude? See here, these 2 points, these places are known as poles and these places are known as equator. Right? Suppose if there is a point mass m, so here is a center, so this angle is known as lambda. Right? At this position lambda is equal to 0, at this position lambda is equal to 90. And my dear students, you already know, आपको पता है that cos 90 is equal to 0. Okay, means there is no effect of rotation at the poles. Why? Because at poles lambda is equal to 90, cos 90 is equal to 0, so at poles G dash is equal to G. And now what is here? The question is, weight of the object everywhere on the earth will decrease. So what's the weight? Weight is, my dear students, mg. Now we can say mg dash, and that mg dash is mg 1 minus r e square omega square cos square lambda. And what is the effect? Rotation of Earth, angular velocity increased. If angular velocity increased, then this factor will also increase. Which factor, my dear students? This factor will also increase. And if this factor will increase, then the weight should decrease, because it is a negative here. So what should be the answer? Answer is except at poles, because there is no effect of rotation on poles. समझ रहे हैं? Yes, see here, if the earth rotates at poles, there is no effect of rotation. Where? At poles. So poles will intact, means there is no change, the weight, no change in weight, which are the objects which are at poles. यानी poles के objects पर कोई effect नहीं होगा, but यहां इंक्रीज होने की वजह से इसमें डिक्रीज हो जाएगा एवरीवेयर एक्सेप्ट द पोल. So this is a very easy question and just you have to remember this formula so you can get the answer. Okay, you will get all PDF. So here I put a slide for you people so that you get the answer. Here, this is the answer. Except at poles, the weight of the object on earth will increase. Okay, got it? So एक क्वेश्चन हमने सीख लिया है. Let's move ahead for the next question. So where is the next question? See here, my dear students. Here is your next question. Also very easy. So read it carefully. Then think about it. Then just answer in your copy. If the radius of Earth, see, if the radius of Earth were to shrink by 1%, shrink, radius of Earth decreasing by 1%, right? And mass remain same, mass में कोई change नहीं हो रहा है. Then the acceleration due to gravity on the Earth's surface. So do we have any formula for the gravitation at Earth's surface? Think about it. क्या हमारे पास सरफेस पर एक्सीलरेशन या ग्रेविटेशन एक्सीलरेशन का कोई फॉर्मूला है? Yes, we have the formula and this formula is gravitational acceleration at the surface is equal to capital G me divided by re square. This is formula for the gravitational acceleration at the surface. तो आप समझ पा रहे हो ना? वेरी गुड. सो देखिए, अगर यहां रेडियस डिक्रीज हो रही है, सो इफ रेडियस डिक्रीजेस मींस द डिनोमिनेटर डिक्रीजेस एंड by the mathematics, basic mathematics, we can say if radius decreases then the value of g increases. So what's the answer? Decrease, remain unchanged, increase. What we have to find? On the Earth's surface, acceleration due to gravity, radius decreases, then g increases. So answer is, my dear student, this. Okay, another very sweet and simple question and also very easy, and you can do it very easily if you remember the concept as well as the formula for that. So you have to remember this formula, right? Okay, चलिए अब चलते हैं आगे और फिर देखते हैं कि आपके पास और क्या है. ठीक है, चलिए. So the answer that you have here, this you can see the answer. Acceleration due to gravity increases. Got it? Very nice. So let's see what is the next question. Very good. See here, a satellite. Another very important must question for you people. You have to remember some certain things about that. See here, satellite revolving in a circular orbit, a height is small h from Earth's surface. A small h from Earth's surface. Got it? Very good. Radius of Earth is r, and see, h is very less than r. Okay, so what you have the formula for the orbital speed? We clear cut have an idea about the formula, but here we are again going to derive or solve just for the revision. Okay, so when it is revolving around the Earth, from where it gets its centripetal force? Yes, it gets its centripetal force, the required centripetal force for the revolution, from the gravitational attraction between the satellite and Earth. Right? So from here you can say required MVO. VO is the orbital speed at height h, so radius is re plus h. This is the required centripetal force, and it is provided by the gravitational force, that is g, mass of Earth me, into mass of satellite divided by RE plus H whole square. Got it? This is actually the condition, yeah, necessity. So M will be cancelled out, RE plus H also will be cancelled out. Then you can say V naught is equal to root of G ME divided by RE plus H. Okay. तो डे स्टूडेंट्स, यहां तक आप सारी बात आई होप समझ रहे होंगे. यू आर गेटिंग ईच एंड एवरीथिंग एंड फीलिंग हैप्पी. ओके, सो नाइस ऑफ यू. चलिए अब आगे चलते हैं, कॉन्सेंट्रेट करते हैं फिर इसी पे. सो वी नॉट की ये वैल्यू आ गई, आपको पता होगी, याद होगी, नहीं है तो इसको याद रखिए, जस्ट अ रिविजन. ओके, यू हैव टू रिमेंबर दिस फॉर्मूला एंड you know better that GME is equal to GRE square. So we can say here GRE square divided by RE plus H. Right? Now see here, H is very less than R. If H very less than RE, so we have the orbital speed V naught root of RE will be cancelled out. We have G RE. Got my point? This is the orbital speed of satellite close to the Earth's surface. Okay? So the orbital speed of any satellite which is very close to the Earth's surface, completing this condition, the orbital speed is under root GRE. Let's say what's the question is. The minimum increase in orbital velocity required so that the satellite could escape. So do you know the escape speed in terms of G and RE? RE, radius of Earth, here it is R. Yes, so the escape speed is, my dear student, VE root of 2GRE, which is more than that. What is the required increment? Required increment is VE and minus VO. So what we can say? We can say here root 2 minus 1 and root GR. Okay, so this is the increment in speed. The question asked about what is the increment speed? Increment in speed so that it can escape from the system or Earth gravitational field. So this should be the answer. Let's see, where is your answer? So देखो बच्चों, here is your answer. A very simple question for you, but by this you can score 4 marks. If you do it wrong, then you will lose, yes, 4 marks. You can get 3 marks, but you can lose 4 marks due to negative marking. So be concentrated and be accurate. Right? सारा खेल स्पीड और एक्यूरेसी का है. इजी, सिंपल, नॉर्मल क्वेश्चंस होंगे, बट आपको थोड़ा सा कंफ्यूज कराया जाएगा. आपको कंफ्यूज नहीं होना है, जल्दबाजी नहीं करनी है और एक्यूरेट रहना है. ओके, सो लेट्स सी फॉर अनदर क्वेश्चन. दिस इज अ वेरी इजी क्वेश्चन. लेट्स सी व्हाट्स द आंसर. सो द आंसर यू कैन सी रूट GR रूट 2 minus 1. सो लेट्स मूव अहेड. Let's see what the next is. Yeah, next is a very good question, my dear students. Yeah, so see here, the question is very good. From a solid sphere of mass capital M and radius R, spherical portion of radius R by 2. Just think about it. Spherical portion R by 2 removed. So what is the mass of this removed portion? M? No. It is a uniform sphere. So mass is equal to volume into density. Density is constant, means mass is directly proportional to volume. Very good. and the volume of this, if you can find, V is equal to 4 by 3 pi r cube. R is, my dear student, r by 2. So what we can say, this is r cube by 8, right? R cube, volume 4 by 3 pi r cube for the bigger one if the mass is capital M. Then for this one, the mass is, yes, m by 8. So here we can say the mass of this one is m by 8. राइट, ये पहले आपके दिमाग में आ जाना चाहिए. क्वेश्चन बहुत सारे करेंगे, प्रैक्टिस करेंगे, देन यू कैन लर्न, यू विल लर्न व्हाट एक्चुअली द करेक्ट प्रोसीजर और करेक्ट मेथड टू सॉल्व एनी क्वेश्चन ऑफ ग्रेविटेशन और एनी टॉपिक, माय डियर स्टूडेंट. सो बी प्रैक्टिस, राइट. सी हियर, have mass of these two removed as shown in figure, right? So this is the center, this is the radius r, and another center of this one, and its radius is r by 2. Okay, very good. तो अब आगे देखते हैं, चलिए, कि हमारे पास और क्या है, क्या पूछा जा रहा है. And removed as shown in figure, taking gravitational potential, V is equal to 0 at r is equal to infinity, right? Because we can never define the potential at any point. It is not defined. Never. We can never. Only what we can define? We can define the potential difference between any 2 points. Right? If we can define the potential difference between 2 points, then if we have to find the potential at any point, then we have to take a reference point with respect to which we can define. So here the reference is infinity, and at infinity, let's see, the potential is 0. So the potential at this point with respect to infinity is supposed to be V, which you have already studied, you might be studied, right? Okay, so if at infinity is 0, the potential at the center of cavity that we have to find. We have to find the potential at center of gravity. This is the cavity. Here we have to find the potential. This is the center of cavity. Okay. So as you know, potential is what? Yes, a scalar quantity. So we can find the potential by adding or subtracting. So first I am going to find the potential due to complete sphere at this point. Let's see, this point is C, and let's say this point is A. Okay, so the potential at point A due to a sphere of mass m is minus capital G m, right? And 3r square minus small r square divided by 2r cube. Okay, so this is actually the formula for the potential at any point inside the surface of a uniformly distributed mass distribution, right? Uniformly spherical mass distribution. For this, the potential inside the surface at a distance small r. Suppose, see here, if you have this point, right, and this point is from the center at a distance r. Yeah, this is the center, suppose. Then you have to apply this formula, and at this point, what the value of small r? Now the small r is, yes, capital R by 2. So what we can say? Minus Gm divided by 2r cube. Very nice. And here 3r square minus. What should be here? Good. R square. R is r by 2, so that is r square by 4, my dear student. Got it? Very good. So let's solve it. Minus G capital M divided by 2r cube. Here 4 3 12 minus 11 r square divided by 4. And here we can say by 4, here we can say minus gm, right? And r square will be cancelled out. So we have 4 2 into 11, 4 to 8 into r. Yeah, this is the electric gravitational, not the electric, gravitational potential due to mass m. Now, what is the potential, what is gravitational potential at point A due to a small mass? Now, we have to find the gravitational potential due to this smaller one. This is smaller one, potential again at point A, but due to m dash. What is m dash? M dash is, let's say, m dash is mass of this one, and that is m by 8. So what's the formula for the potential at the center? That is 3 by 2. Point to be noted. Many of you will confuse at this point, but point to be noted, if there is a uniform distribution of mass in a spherical region of radius r, then at the center the potential is minus 3 by 2. See here the formula, minus 3 by 2 g m, that is m dash, divided by r. R is r by 2. The radius of this sphere is r by 2. So 2 will be cancelled out from here, my dear students, and you'll get minus 3 g m by 8 r. Okay, this is the formula for only this part at the center, and this is the expression for the gravitation of this complete part due to this complete part at point A. And as you know, it is a scalar quantity, so we can subtract. Now, what is actually the expression for this type of sphere in which there is a cavity, right? So we can, what is now the net potential at A is VA due to M minus VA due to M dash, right? So what we have VA as M minus 11 GM divided by 8R, right? Minus and this minus will be, minus and minus will be plus, and then we have plus, right? Plus and 3 GM upon 8R. Got it? Then we'll get minus 8 GM upon 8R. Now 8 and 8 will be cancelled out, and you have minus GM upon R, right? And this is your required answer. Got it? So the answer for this question is, you can see here, minus GM upon R, that is A option. Okay, so let's see. A option is the correct answer. Here you can see the correct answer is minus GM upon R. So again, let's see another one. What we have? See, G is acceleration due to gravity. G is acceleration due to gravity on a surface. Gain in potential energy of an object of mass m raised from the surface of Earth. Okay, so this type of question is a little bit confusing. Let's see what most of the students will do due to this. As you know, here is the center, this is the radius r, and according to the question, if we raise the height smaller, so from the surface the increment in height is r, so you'll say that change in potential energy or gain in potential energy is mgr, right? And mgr is also in option, right? And then you will mark this, but this is not the correct one. So think, what's the wrong with it? Yes, because the potential energy is equal to mgh. This formula is applicable only if h is very, very less than r. But in this case, h is not very less than r, my dear students. So what we have to do? Just we have to proceed with the basics, right? Initially, the potential energy, let's say 1, or you can say P, potential energy I. If it is at the surface, then you have minus GMEM divided by RE, right? Finally, at height, at what height? Yes, at height R from the surface. The gain in potential energy of the object mass m raised from the surface of the earth to a height equal to radius r. Now you can say you have minus GME m upon twice of RE. So what is the gain in potential energy, my dear students? This should be final minus initial. So potential energy final minus, dear student, potential energy initial. Got it? When you will put this, then you'll get minus G capital MEM upon twice of RE plus G capital MEM upon RE. Isn't it? Yes, very good. Are you getting my point? Are you getting me what I am saying? So nice of you. See here. So you get change in potential energy 1/2. So we get plus. Plus means gain in potential energy. And this is G ME is small m upon twice of RE. Got it? And see here. What is this? What is this? This is G into R. If G is the gravitational acceleration on the surface, so from here you will get half mgr, and this should be your answer, not mgr. See here. Okay, so this is a little bit misconception maybe in your thinking. So think carefully and always remember the formula with specification, because mgh, change in potential energy, mgh is the formula is applicable only and only if h is very, very less than r. Okay, but if not this, then should be solved like this. Okay, so let's see, and here is the answer. So let's verify it. Yes, it is the answer, not this. See here. Okay, so again there is a small announcement for you people. Listen it very carefully. This is your masterclass physics for JEE and NEET, and this announcement is for the batch in which we daily listening, with daily dealing, with daily learning for these type of concepts and all the chapters going on, right? And the classes are going on, already started, but the registration for the batches are going on. And here this is JEE 1 year long term course for you people. And dear students, here the batch is already started from 25th March 19, but the registrations are going on. Okay, and the registration on going on, so you can register yourself for this, in which we will enjoy the physics, we will learn the physics, and definitely one day we will crack IIT JEE. Okay, and all these master classes as going on here, and here we are doing just fast track revision, so theory portion and the formula derivation is not covered here. But in master class we learn each and everything, derivation, formula one by one, okay, due to in a slow manner, understanding manner, so that you can understand it very well. Okay, so for fees for this course was 79,000, but for 2 hours or 3 hours for you people there is a lightning price, and this lightning price is 69,000. Means you can get this course or this batch for 69,000 now. So don't late, just you can enroll yourself by clicking this link, and there is also a link in description box. So just click on that link and go to the page, welcome page, course registration page, and there you can get a discount of 10,000 rupees for this course, and you will register for the master classes that are going on in PACE. Right now we have some more to go. Here we have another question, another very easy question for you people. See the question first. The question is, what is the minimum energy required to launch a satellite? Right, a very good question is it. Mass in form of surface, planet of mass m and radius r in circular orbit. Means we just have to find the energy required. Okay, so see here, there is a planet, mass m, and its radius is r. Right, altitude of the satellite, if we launch the satellite, it is at the altitude of 2r, so this distance is 2r. Actually the radius of this orbit will be 3r. So let's say the speed of this orbit is, required speed is supposed to be v. If its speed is v and it is revolving in a circular orbit, then there is a requirement of centripetal force. Right, students? So from where it will get the required centripetal force? The required centripetal force is provided by the gravitational acceleration between the planet and the satellite. Right, so let's see, the required centripetal force is, my dear students, mv square divided by 3r, and the gravitational force of attraction is g capital M small m divided by square of 3r, so you get 9r square. So r will be cancelled out, 3 and 3 here, m and m. From here you get that v square is equal to what? G capital M divided by 3r. Right, this is the value of v square. What's v here? V is, yes, orbital speed of satellite. Okay, if v is the speed, so it has a kinetic energy, my dear students. How much the kinetic energy it has? It has the kinetic energy half mv square. So we can say half mv square is capital Gm upon 3r. So the kinetic energy that it will have is G capital M small m divided by 6r, my dear students. Okay, this is the required kinetic energy. And one more energy is there. बोलो कौन सी वो energy होगी जो दूसरी है? Yes, another energy is potential energy. So what is that potential energy? Let's see the potential energy. That potential energy, my dear student, is equal to, yes, negative G capital M small m divided by, yes, 3r. Okay, got my point? So you can say that potential energy is equal to minus twice of Gm small m by 6r, isn't it? Obviously. Okay, so what is the net energy or the total energy? So the total energy of that satellite is just kinetic energy plus its potential energy, right? Now we have the formula for this. We can add one energy is positive, another one is negative. So we have the total energy minus G capital M small m divided by 6r. This is the requirement of energy. Okay, so if this is the requirement of energy, so at this point this is the total energy. Okay, but from where we have to launch? We have to launch a satellite mass m from the surface. Means at the surface it already has some type of energy. Which energy? At surface it is at rest. So at that point it also has some energy, which is a potential energy. And that potential energy which it already have is minus G m small m divided by r. Okay, so what is the requirement of energy? So the requirement of energy is the difference of these two. So if we have to take the difference of these two, so what is actually the difference of these two? Just minus, so it is plus, then 6 and there 6. So it has 5 positive G m small m divided by 6r. So this is actually the required, this is the total energy of the satellite. But initially it is at the surface of Earth. That's why we have to subtract that much energy here, right? This is the key concept. Otherwise you get incorrect answer. Okay, so for the correct answer we have to subtract that energy. If we subtract that energy, then the requirement of the energy is this. So let's see the options, and here are the options. Okay, so the correct answer for this question is yes, A. So let's check the answer. Yes, you can see here 5 Gm small m upon 6r. This is your correct answer. Okay my dear student, आ रहा है मजा? रिवीजन हो रहा है? रिवाइज कर रहे हो? Very good, very nice, so nice of you. Okay students, let's see another question, another must and must question. So here it is, another question, right? So another question is, see here, a satellite is moving in an elliptical orbit around the Earth, right? Mass of the satellite is very small compared to the mass of the Earth. Elliptical orbit around the Earth. See here, this is the elliptical orbit, let's say, and here there is a Earth, and here a small satellite that is revolving, and at any point it has some speed v. Okay, so what is the force acting on it? The force acting on it is F, and this is the gravitational attraction. Wherever it is, the force is always directed towards the Earth. Velocity may be like this, maybe like this, maybe like this. When it is at this position, again force is like this. Okay, so force is always right towards the Earth. So first option is acceleration of S. S is satellite. This is the satellite. Acceleration of S always directed towards the center of Earth. acceleration is always directed towards the center of Earth. So it is correct, because the only force is acting on it is, yes, gravitational attraction, and that gravitational attraction is always directed towards the Earth. That's why it's acceleration, because acceleration comes from external force, and that external force is always towards the Earth, so acceleration is always towards the Earth. That's why this option seems to be correct. Okay, so let's see another one. Angular momentum of S about the center of Earth changes. Angular momentum changes in direction, but its magnitude remains constant. Right? Changes in direction. What's the angular momentum? Angular momentum is L is equal to R cross P, cross product of R and linear momentum. So see here, this is R here and is V, linear momentum. So from right hand rule you can say, R, see here, R cross P, always R cross P. So direction of angular momentum is always perpendicular outward from the board. It means the direction will not change, right? And magnitude also will not change. Yani angular momentum of satellite about the Earth is always remains constant. Why it remains constant? Because the torque about the Earth is always zero, and due to conservation of angular momentum principle, the angular momentum of any object remains conserved or remains constant about the point about which there is no external force, right? So for this satellite only the force is towards the Earth, and the torque of that force about Earth is zero. That's why angular momentum remains conserved in magnitude as well as direction about the Earth. But here angular momentum about the center of the Earth changes. That's why this option is, yes, incorrect. Rotational mechanical energy of S varies periodically with time. No, it remains constant, conservation of energy. Linear momentum remains constant. No, because linear momentum changes in magnitude and also in direction, right? So here we cannot say about this. So the correct option is only A. Let's check the answer. So you can see here the acceleration is always directed. So first is the answer. Got it? Okay, let's see what is the another question. Yeah, that's also very important but a confusing one. See here, what is this? A double star system consists of two stars A and B. And what is this? This is known as binary star system. If there is a binary star system, maybe one is M1 and another one is supposed to be M2. And here is the center of mass. AB, which have time period T and TB and radius. So maybe you think that T square is proportional to R cube. If R is greater, so TA is greater, R is less, so TA is less. So maybe you will write this answer, but this is not correct, right? Because of this is a binary star system. Binary star system, in binary star system, satellite, sorry, not the satellite, stars are always revolving. Yes, in binary star system, stars are always revolving around their center of mass, right? And the force due to mutual attraction या gravitational force of attraction between them provides the required centripetal acceleration. So for required centripetal acceleration, there is only and only the gravitation force. That's why that gravitational force should always be directed towards the center, right? So it is possible only when they are always in a straight line while revolution. Means when m1 is here, then m2 should be here. When m1 is here, then m2 should be here. Why? Because only this manner the force is always towards the center, right? Here. Now force is always, what is the force? That force is gravitation attraction. That's why in binary star system, this is the radius r1, this is the radius r2. The condition that t square proportional r या t1 square proportional to r1 cube is not valid, because in it ta is equal to tb, because they revolve around their center of mass with same angular velocity as well as same time period. Okay, so ये अपना आज के सेशन का, this is the last question for today's session. I hope you will enjoy a lot. If you enjoy a lot, then just like and share the video and give your comment, valuable comment in comment box. And we just going to stop the session and hope we will have more session of this type in which you get the questions and their solution which are a little bit confusing. Okay, so I hope आपने enjoy किया होगा, अच्छा लगा होगा, मजा आया होगा. मैंने भी आपको इतनी चीजें सिखा के बहुत enjoy किया and I feel highly obliged. Right? Okay guys, thank you. Bye bye.